Hi and hola para amigos. There is an ongoing transformation in medical education, shifting from the era of information to artificial intelligence. However, this shift raises concerns about data privacy and security. AI is addicted to our data, and the data are stored and processed in centralized servers, granting the owners of these servers the ability to analyze us. In response to these concerns, humanity sought solutions, leading to the development of distributed ledger technologies like blockchain and Holochain. The idea is, if we distribute the data and cryptographically sign, the problem of reliance to third-party intermediaries, who are server owners, disappears. No more middlemen like Amazon Web Services, banks, or notaries. No intermediaries collecting or selling your data. Ownership is in your hands. However, some of these technologies consume substantial amount of energy. The environmental impact of these tech on planetary health and medical education hasn't been explored. This video delves into the exploration of this important issue. It provides two key recommendations for medical education researchers, educators, and policymakers on how to utilize these technologies in a manner that reduces negative environmental impacts. These flamingos are ready to start. Imagine blockchain as a digital ledger that securely records transactions. Unlike traditional ledgers, copies of this digital ledger are not stored in one place. Instead, they're distributed across many computers globally. This decentralization removes the need for intermediaries like banks and ensures transparency. Now, some blockchains, such as Bitcoin, use a consensus mechanism called proof of work. In simple terms, this involves miners, a network of computers, solving complex puzzles to validate transactions and add them to the blockchain. The downside is that this process consumes a significant amount of electricity, which has raised environmental concerns. Estimates even suggest that the energy consumption of the Bitcoin blockchain alone could contribute to a temperature rise of up to 2 degrees Celsius globally in the next few decades. However, not all blockchains operate this way. There's an alternative consensus mechanism called proof of stake. In proof of stake blockchains, instead of miners competing to solve puzzles, nodes, computers, validate transactions and add new blocks based on the amount of cryptocurrency they hold or stake on the network. This approach is designed to be more energy efficient. A notable example is Ethereum, a popular blockchain network that transitioned from proof of work to proof of stake, reducing its energy consumption by over 99%. This shift was motivated by the desire to decrease the environmental impact associated with blockchain operations. This brings us to the first recommendation. If the use of blockchain technology is necessary, avoid using proof of work blockchains. Certainly, we understand the reasons for avoiding proof of work blockchains, but why is there an emphasis on assessing the necessity of using blockchain technology? In simpler terms, blockchain technology has been suggested as a way to enhance the security and privacy of data. People thought it could build trust among different parties in education, like universities and students. Specifically in medical education, it was believed that blockchain could efficiently track educational activities and provide an accountable mechanism for dealing with observations in entrustable professional activities, removing the need for third-party intermediaries in certifications and credentialing. However, in practice, the use of blockchain has mainly been limited to tasks like verifying identity and certifying degrees. For instance, some researchers tried using blockchain to automate the accreditation process for medical education credits, but it didn't gain widespread acceptance. The challenges include legal issues, the immutability of records on the blockchain, and scalability problems. Despite attempts to address scalability problems, the data-centric nature of blockchain continues to present challenges that hinder its broad adoption. While decentralization is important, some experts stated there are reasons to be skeptical about blockchain and its application to healthcare professional education. This brings us to the second recommendation. Use Holochain instead of blockchain. Holochain is a framework for developers. It's open source, meaning anyone can use it and contribute to it. With Holochain, developers can create applications that don't rely on a central server or go through middlemen like miners in blockchain. It operates truly peer-to-peer. Unlike blockchain, Holochain lets each participant in its network have their own computing power. Think of it like everyone having their own mini-computer in a network. This means they can interact directly with each other without needing a central authority overseeing everything. One cool thing about Holochain is that it avoids what's known as the scalability trilemma, a challenge faced by many technologies where they struggle to balance security, scalability, and decentralization. Holochain manages to solve this issue with its unique agent-centric approach, which focuses on individual participants rather than just the data. This means developers using Holochain can build applications that are truly peer-to-peer and can match the performance of centralized applications without sacrificing security or decentralization. Holochain has been been demonstrated to create a radically distributed system for health data. What's fascinating is that Holochain's design allows for a unique kind of governance in healthcare and education systems. It enables a distributed, participant-led model that can be tailored to local needs and values. This means decisions in medical education can be made in a way that's responsive to the specific requirements of each community, making the whole process more sustainable and fair. For the first time in medical education, challenges related to sharing and validating data, like tracking educational activities or ensuring accountability, can be addressed without sacrificing scalability. In simple terms, Holochain is offering a way to make these processes more efficient and secure without sacrificing decentralization, which is quite groundbreaking. Additionally, it would better to mention Holo as well. It is like a special hosting platform for Holochain applications. Holo acts as a hosting infrastructure for these apps. Developers can deploy their decentralized applications without dealing with the technicalities of managing their own hosting infrastructure. How does it work? Well, individuals like you and me contribute our unused storage and processing power in our personal devices. In return for lending our computing resources, we get paid in a digital currency called Holofuel. It's a bit like how Airbnb or Uber works, where people contribute their homes or cars. Now, considering the impact on the environment, Holochain and Holo's infrastructure model is designed to be eco-friendly. Unlike traditional hosting models or energy-intensive blockchains, Holo utilizes the spare capacity on personal devices, reducing the need for big, energy-hungry data centers. This makes Holo a greener alternative for hosting medical education data. In simpler terms, Holo is creating a system where individuals can share their computer resources, get paid for it, and contribute to a more environmentally friendly way of hosting digital applications in a decentralized way. It is important to note that while Holochain and Holo offer considerable benefits for planetary health, they lack extensive real-world testing compared to blockchain and traditional hosting. Therefore, a gradual transition is advised to prevent potential adverse effects. However, considering the security and privacy concerns of centralized solutions and the limitations of blockchain technology, Holochain appear to be a viable alternative. Based on the potential benefits highlighted, it can be recommended to use Holochain technology instead of blockchain to address critical data issues in medical education. If you want to read more on these technologies in the context of medical education, you can find links to the related articles at the description below. See you and adios para amigos. And also, don't forget these flamingos.